Let's solve a problem about the distance traveled by the tip of a clock's minute hand. The minute hand is 6 inches long, and we need to find how far its tip travels in 15 minutes, 30 minutes, and 1 hour. Let's visualize this with a clock. The minute hand moves in a circle with its tip tracing out a circular path. The radius of this circle is 6 inches, the length of the minute hand. To find the distance traveled by the tip, we need to calculate the arc length of the portion of the circle it traces. The formula for arc length is distance equals radius times angle in radians. Let's start with 15 minutes. In 15 minutes, the minute hand moves 1/4 of the way around the clock. That's 90 degrees or pi over 2 radians. Plugging into our formula, distance equals 6 inches times pi over 2 radians, which equals approximately 9.42 inches. For 30 minutes, the hand moves halfway around. That's 180 degrees or pi radians. The distance is 6 inches times pi, which equals approximately 18.85 inches. Finally, for 1 hour, the minute hand makes a complete circle. That's 360 degrees or 2 pi radians. The distance is 6 inches times 2 pi, which equals approximately 37.7 inches. Let's summarize our findings. In 15 minutes, the tip travels 9.42 inches. In 30 minutes, it travels 18.85 inches. And in 1 hour, it travels 37.7 inches. Notice that the distance doubles from 15 to 30 minutes and doubles again from 30 minutes to 1 hour. This makes sense because the angle covered doubles each time.